we can write a Ka for an acid. And this is just an equilibrium constant for the acid. So we've got our equation here. So we put products on the top. Reactants on the bottom. And H plus does not equal H3O plus, but the concentration of H plus is equal to the concentration of H3O plus. So you'll sometimes see them both being used. So if we look here, our H3O plus, which H plus is the same thing, on top, our A minus on top, and our HA, the whole acid, on the bottom. Remember from our equilibrium chapter, pure liquids are not included. That's why we don't do water. So our Ka for H2CO3. Notice it says for the first hydrogen. So that means H plus is our first thing, and everything else that's left. HCO3 minus. Then on the bottom, the whole thing together. Oh, up here I did another one, acetic acid. So our Ka would be H plus, and then the acetate ion over the whole acid. The larger the Ka, the stronger the acid. So you can use that to compare. Strong acids completely ionize, and we don't do Ka for those because it is essentially infinite. And there are only 6 strong acids. That'd probably be a good thing to memorize. And we did actually look at these with solubility rules. Now, weak acids do not completely ionize, and the stronger the acid, the weaker the conjugate base. So we have HCl is an acid, strong. So Cl minus is the conjugate base, and it is really not a base at all. But C2H3O2, a weak acid. So C2H3O2 minus is the conjugate base, and it actually is a base. Now, in order to order these from strongest to weak acids, we are going to need to use Ka values, which we're going to have to look up in a table. But one thing we know right away is that this is a strong acid. All of the rest are not. So if we're going from strongest to weakest, then that is our strongest one. All right, so if we look up Ka values, we get that this one is 1.2 times 10 to the minus 2, and NH4 is the conjugate acid from NH3, which has a Kb of 1.8 times 10 to the minus 5. Okay, this question actually seems like it has jumped ahead because Ka times Kb is equal to Kw, which is 1 times 10 to the minus 14. So to find the Ka, you have 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5, which gives us 5.6 times 10 to the minus 10. And so we're going to do HClO2, and then NH4 plus, and then water.